Okay, question 60. P and Q are real numbers, and the equation x times the absolute value of x equals px plus q has exactly k distinct real solutions for x. Which one of the following is the complete list of possible values for k? Good. Okay, so, again, you know, if you do enough TMUA or MAT questions, you know that if you want to find a number of solutions, you always draw the graph. Okay, there's no escape. All right, so let's try to draw left-hand side. This might look horrendous, right? But actually it's not too bad, right? If x is positive, then this is essentially just x squared, right? If x is negative, all right, let me mark this down. So x squared equals 0. What happens when x is negative? Then it's just negative x squared, right? Okay, so that is actually not too bad, right? It's just a piecewise defined function, which is perfectly continuous. So let's do this. So how do I draw this? Positive x squared, negative x squared. All right, so a perfectly odd function. Good, okay. How about the right-hand side? The right-hand side is px plus q, and I have no restriction on the choices of p and q, right? It just says it's real numbers. So px plus q is just random straight lines, random linear functions that I can draw on this graph, right? Okay, so let's try this. Okay, the most straightforward thing to do is do something like this, right? That's one solution, right? So, okay, not D. Great. Okay. Can I get two solutions? Can I possibly get two solutions? Yes, right? You just got to be very careful, and you just try to do something like this, right? You tangent at this one, okay? You tangent at this one, and then you actually cross the other one, right? Then you can get two solutions, right? Okay, that doesn't eliminate any of the options, so not very helpful, okay? But what else could you do? You could also get three options, I think, right? Three roots, I mean. Yeah, because you can do, say, like this, right? And then you get three roots. Okay, so 3 is possible, so not A. Good. Okay, can I possibly get 4? So I think if you keep on trying to rotate the line and then move the line up and down everywhere, I don't think you can quite get 4. Yeah. Okay, so not 4. So bye. Okay, how about 0? Okay, so 0, what's the best way to try to do 0? I mean, if you go like vertical lines, you're going to hit the quadratic somewhere, right? If you go horizontal lines, then it also hits the quadratic somewhere, right? Because it has infinite domain and it has infinite range. Okay, I don't mean infinite, but the domain and range are both the whole real line, right? So any vertical or horizontal line won't work. So if the horizontal lines and vertical lines don't work, then naturally the diagonal lines don't work, right? Because the diagonal lines are just a composition of the vertical and the horizontal lines, right? Okay, so that proves that 0 is not possible. So therefore, final answer will be E, 1, 2, and 3 only.